Are we all back? Good. Okay. Let's continue then. So we've talked about privacy and privacy enhancing technologies, and the good news is this afternoon Professor Somanath Tripathy is going to teach you about homomorphic encryption in detail. Okay, so he'll tell you about the different flavors of homomorphic encryption and show you how it applies to cloud security. Okay. Yeah, I might just do one little thing on PEX before that, just after lunch, just to show something, because I saw your slides. Okay, but what I want to talk about now is something that is really important that we've got to think about. And actually, people don't think about it early enough in designing systems. Security is often an afterthought in designing systems. Yeah, and the reason is, you know, some startup gets an idea and they do something, think, well, you know, if it gets big and important, then I better secure it. But I'm not going to spend a lot of time putting security into a solution, yeah, because all other people are innovating all the time, and if no one buys it, I don't need the security, right? So it's really important to have security early on, but we've got to understand that people don't do that. Yeah, so that's why we continue to have insecure systems. That's why the OWASP top 10 doesn't change very much, right? Because people want to build quickly rather than build securely. So the secure development lifecycle does add in some extra costs. But what we've got to think about now is that there's been increasing number of attacks that have happened through the supply chain, and I'll talk to you about supply chain security tomorrow or Thursday. But where we are is everybody's got to have considered if their product or service scales, they are increasingly becoming part of what we call the critical national infrastructure. Yeah, so critical national infrastructure are those areas where any sustained period of disruption would materially affect society and potentially life. Yeah, so there's different countries have different approaches, and I think the US has many different categories of what it calls critical national infrastructure. The UK just has 13. One of them is food, for example, right? Another is transport, another is energy. The transport infrastructure stops, then we can't get food around, we can't go to work, etc. There's all sorts of problems. If we don't have food, problem there. We don't have energy, but there's 13 different categories. And what we've got to think of is, as we develop something that becomes important, it's not just personal, but it's commercial, then we need to make sure that we work together on solving, ensuring security. So you saw that zero trust architecture I said, and I said gain cyber threat intelligence, get ways to share information. So there are some important mechanisms that anyone designing a system or having operated a system need to be aware of to get support. And I'm going to go through some of those today. And I'll first of all start with the UK. Then I've mentioned already CISA in the US, they've got security controls there, center. But I did look today to see what the two Indian authorities were, because I asked you yesterday and I didn't get a concrete answer. So we'll go through that. But it's important to see what governments can do to support you. So in the UK, we have the National Cybersecurity Centre, Yeah, and they are what's called our National Technical Authority on Cybersecurity. So they don't do the policy work, that's government, but they're the technical authority. And I mentioned before, we've got these academic centres of excellence in cybersecurity research, 21 of them. We've got Cyber Invest, which is encouraging industry to invest in academia. And we've got some research institutes. So one's in Trustworthy Interconnected Cyber Physical Systems, RITICS, one in Hardware Engineering, RISE, one in Socio-Technical Cybersecurity, RISKS, and one in Verifiable Trustworthy Systems, RIVETS. So these are national centres where we come together and we do the research, yeah? And we provide, and we work with NCSC to provide guidance for individuals and industry. Now, one thing I'm going to say is next week I'm supposed to go straight from here back home for one day. I was in Singapore last week, back home for one day, and I was supposed to go into Germany. Got to see, I probably will go. But I'm looking at, we're having a meeting for space cyber systems security. Yeah, so space is one of the critical national infrastructure. Yeah, and for that, there is something called, in the US, called space, it's for space, ISAC. And these are important ways for us to gather intelligence. The ISAC is an information sharing and analysis center, okay? So that constantly, it's got a watch center that constantly scans the dark web, CVEs, common vulnerabilities and exploits, yeah? It is looking for emerging threats and gives it out as a feed to different people that subscribe and are part of it. So the Information Sharing and Analysis Center is a way that you can share information, and the NCSC has similar forums. There may be ones in India that are similar, but some of the ISACs are global. There are ISACs for the financial services sector, there are automotive ISACs, there are energy ISACs. So it's one source of threat intelligence that we can use. The NCSC also provides guidance that is useful for any of you that are developing systems that you're hoping to deploy. So they have the 10 steps for cybersecurity. They've had this for a long, long time. And they talk about the first stage. This is in some ways similar to CISA's 18 controls that they have. But they say some of the important elements are risk management, for example, right? So take a risk-based approach to your cyber security, okay? They say ensure that you have engagement and training. So this is really important. So I've written some papers before on why do employees fail to adopt security practices, or how do we encourage them to? So there's some real organizational and psychological theory behind why people do or don't. So one thing you have to do is engage in training. That will stop some of those attacks that I showed you yesterday. Help reduce the number of phishing attempts. It would help stop social engineering attacks, yeah? So getting an engagement in from employees is really important. Manage your assets. We've got many more tools now to help us with asset management. I mentioned yesterday in Zero Trust Architecture, so you'll notice I'm coming back to Zero Trust a lot, because I think it is the future, we're already doing it, which says manage your assets. If somebody's got bring your own device, so it's not a managed asset, what we need to do is say, well, what do we require on that? So how can we fully manage or partially manage? Get the correct architecture and configuration. Have vulnerability management, so keep your systems protected throughout the life cycle. So that means vulnerability management means is when you have a vulnerability, and has anyone seen a threat intelligence feed from something like this? You get loads coming through every day, right? Loads, and it'll collect information from Google and from Twitter and from this and that, yeah? But what you have to do is when somebody releases a CVE or an alert, you need to make sure that you're ready to patch your system, because very often, yeah, when a vulnerability is detected, it's quite quickly patched. So you need to make sure that you are patching quickly, which is why some people like this machine, it's really annoying, because sometimes it'll say, right, you're going to apply the patches now, and I'm in the middle of doing some work, and I say, no, do it later, yeah? But the reason they do that is vulnerability management. Identity and access management. So we talked about access control. I think you just mentioned it before. So how do we do the correct identity and access management, access control? Data security, wherever you've got data, and it still surprises me that data is unencrypted on central servers. Many people will have unencrypted data on their laptop, yeah? Have to live with that. Reason people have it unencrypted on the laptop is it's a little bit of a pain to access everything if you've got to prove who you are. That's the problem, you see. So that takes time and typically an interaction, because there's no point this being encrypted, but as soon as I log on, you know, if it's logged in, it's all unencrypted, and that would take a lot of cost, right, to have it encrypted, then decrypt everything because I've logged on, then re-encrypt it when I log off, yeah? So it's awkward, so it's got to be usable, but in central servers, when you're not accessing data all the time, there's no reason for it not to be encrypted, really. But data security, logging and monitoring, so using your SIEM type systems, looking for any incidents and events, and after that, incident management. How do you react when there's been an incident? And finally, supply chain security, which is one of the hardest challenges, I have to say. And the reason for that is that supply chains are often invisible. You can't see into your providers' operations very easily. Okay, this is one thing we're going to do. In fact, I'll have to see if I can open it out to you at all. If not, maybe I'll see if. Oh yeah, because you're not all here. But has anyone done a cyber exercise before? No. So sometimes they're called TTXs. So they're very often run in organizations. They're for systems that are typically deployed, yeah? But a cyber exercise is where you imagine you have a cyber incident. So if you are working in industry, so you've done your degree in computer science or mathematics, your BCom, whatever it is, yeah? You go into industry, and good practice with that industry, and especially if it's sort of government, will be to run some cyber incident exercise. And that it's a training event. It will gather a small number of people, a sample of people across the organization, yeah? And what you will do is you will have some cyber incident to deal with. So it will be a scenario, yeah? And that's why it's sometimes called a tabletop exercise, yeah? And what happens is you play through the scenario. It's like a war game, yeah? So you work through the scenario, and then it is observed by somebody. And what they're doing is trying to find where are weaknesses in your system, yeah? So in your response. So building trustworthy systems is definitely technical, right? There's some technical element. Yeah, but you are not going to be doing very often, most of you in this room, most of the people I speak to are not going to be doing the homomorphic encryption that Somanath's going to teach you about, but they're going to be consumers of that. They're going to use it, right? So one of two of you will have to go into some deep maths, but most of you will not. You'll be using systems. You'll have to understand how they operate. You'll have to understand how to configure them, and you'll have to understand what to do when it goes wrong. So a cyber incident exercise has got these 9 steps that you run through. So first of all, you decide what do you want to exercise. So you might say, so an example would be, let's say your company sells, IT components, so some peripherals, and some storage